So perhaps a reason why, excuse me, that number 8 could possibly look so confusing is that somewhere that's toluene, somewhere there's a methyl group on here. Right? I think it's down here. All right. So in this case, it's saying we're adding 2-chloropropane. All right. And even if we stopped there, could we proceed any further? It's a trick question. We could not. You are correct. Okay? So I'm willing to bet, does it say a metal catalyst of some sort under there? That is a metal halide or a metal catalyst. Okay? So again, this is number 8, I think we said. Over here, 1 or 2 products. You are going to have 2. That is correct because remember, if there's something on this ring, this is directing whatever it is you're reacting to where it's going to attach. Then the next thing you'd have to look at, okay, is there something here? Yes, there is. It'd really be confusing if we had heat under here. I don't even know if that would even be possible. Because if we had heat under here, what would that possibly mean? They would combine, and I really don't think that would be a low-down dirty trick to put something like that on, and I don't even know how you would attach that. But in this case, since that's not being added onto there to give us one product, it's going to be predetermined by this and that you don't get one product, but rather 2. Okay? And how would we know that there's 2? Yeah, because of this director here is telling you on that chart in the upper left-hand corner that probably has those top 3 or 4 that are para and ortho directors as opposed to your nitro group, which is a meta director. So then, since that has been predetermined, well, not predetermined, but we know that now, and I'll put the next one down here. So we can just basically call this Rx as well because it's got R, an alkyl group, and here's X. So this whole thing is going to attach onto there, but the tricky part about that is you have already answered that already, but why is this tricky when this perhaps attaches onto here? You got to lose something. Again, you know that already because we discussed that. Yes. So what that means, somewhere, probably here or somewhere on this end, or even if you put that on there, I don't think that would be wrong either. But we're not concerned about how that's going to take place. We just want you to know that there's 2 products on there. So in regards to here, where can we attach this? Okay, so either down here, which we're not going to do because of that plus sign, so we're going to attach that up here. So what that means is we would not have CH3. We're just going to say this one's gone. Okay, so we'll put a circle around them because that's now a carbon-to-carbon bond. Here it's a carbon-to-hydrogen bond, so that is now attached. And then you just have to do the same thing where it's going to be directed on this ring. So here's the ortho position, which means you're going to shoot them over there. All right. So put another notch on the belt last night. Is it brown hard to see?
I just can't really see that well. So.
Oh, all right. Well, it didn't look like that last night, I don't think. Did it? Like I said, put another notch on the belt. I was starting to see that, but when I see students squint their eyes, it kind of is a distraction, saying, is everything, we've got a headache or something to that effect, or we're doing science, so yes. I don't know. But very good, very good. Last night, like I said, put another notch on the belt, one step closer. There again, if we wouldn't have signed all these pesky papers, then maybe we'd have a little more free time, but darn it. Yes.
For number 11, it's like, starts off with a double bond.
Okay. And what are you reacting that with?
Nothing, like it's a propane, but it's like,
Oh,
I'm confused with how you use C3H7.
all right. So what that means then, all right. So in this case, somewhere on that ring, this is going to proceed to react because we've got a hot acid here. Well, maybe not necessarily hot. Okay. But like for instance on this chart, we're starting here because we've got that on there. And then up here it says any alkene, which is kind of like an alkyl group. When that alkene is going to react with an acid catalyst, that means that alkyl group is going to attach. That double bond is then going to break. And you also have to remember what is on the outside of all of these right now. We just don't draw them. It's just understood that they're there. You have all them hydrogen atoms on there. All right? So what that means then is that's just going to get replaced and this double bond is going to break. But still, one of the things to keep in mind is that that could only ever have two bonds on it anyway. Because if we scratch this one off, there's 1, 2, 3. Where does this get its fourth bond from? Do you think? From the ring structure, because this is going to be a carbon-to-carbon bond, where this is a carbon-to-hydrogen bond right now. So that's what happens then. Just a different way of writing it. Okay. So CH3, all right. This one only had one, but remember there was a hydrogen on there that's going to attach onto here. So that's one of these guys, and then CH2 here and here. So you're taking any alkene, that's what that chart's telling you, any alkene, doesn't matter how many. If it's an acid catalyst, that bond breaks and attaches to the benzene ring.
You know that one up in the left corner that's all by itself?
Yes.
Is it, so it's KMNO4 is being added to it, but is it just that? Like, I figure out how to ask this. Come here.
Does it mean,
Like,
are all them carbons going to attach? No.
like, this is being added to it, right?
Yes. Okay.
Would this be
That's the same. That's a different oxidizing agent. That is, it will do the same thing.
okay.
If that answers your question. Yes. Okay. So yes, that will become more important when we talk about alcohols next chapter, when they become oxidized, because what does that say? KMNO4, and then K2CrO7 is the dichromate ion. Both of them are powerful oxidizing agents. And that's all it's doing. It's oxidizing this to get that attached to the ring and form an acid. And I think, and there's a lot more to just standing in front of here and trying to teach the content. We're supposed to be maybe entertaining of some sort, and then when we try to be entertaining, we start to yawn, and no, it was bad timing on your part, or just happened to be observant on this part. But a lot of you are doing that cooperative learning. That is a good idea. You're helping each other out. But keep in mind, when you get further down the line in college, okay, don't be afraid to pick up that textbook. When I say, I don't want to do that, because some of the questions that you were asking, they're very, well, maybe it's unfair for me to say, pretty clear examples in your textbook that you would see on this paper. But that there again, that's a learning process. That's something that we really can't, we'll try to instruct you people, but don't be afraid to do that when you get out on your own. That's perhaps a life skill. And asking questions, that's another life skill that's perhaps tough to do. I think you could ask any college student now, I don't want to ask any questions. Why do they not want to ask questions in a college classroom? They don't, you got to get over that. Who cares? What's more important, sounding dumb or actually getting the information they actually need? I would like to think you really wouldn't care what people think. and that's probably tough to do. Do you think? Is that tough to do? I would say that's pretty shallow too, isn't it? My gosh. The reason I say shallow, you said they're pretty judgmental. Why would someone judge someone else because they're asking questions? Now, if there's an overabundance one, I was sitting in a class through down the University Center, it was through SDSU, and it was it a physiology class? There was, gosh, and I don't know, I just chose to sit in the front row, and then there was a gal to my left. I think she was going to go into the nursing program at Augustana, but she needed this class, and maybe it was some of them behind me too. And there was this older guy who just kept asking question after question after question. And I looked over, and she just rolls her eyes every time. I thought that was kind of funny, and the reason that was probably so frustrating is one of the things that we've talked about in anatomy and physiology as well. Probably 55 to 60% of your success in college was not just going to class, but doing what? Just listening. Some of the questions that he was asking, if you would just listen, but that's another acquired skill, is what do you think is important to write down? And what do you think we would suggest on our end? If we're standing up here writing something down, do you think it's probably a good idea that you would do the same thing a year from now? I highly, highly suggest you do that. If they're taking time to do that, there's probably a good reason for it. All right. I don't want to take up too much of your time because I know, do we feel the crunch of, it feels like the walls are coming in? Does it feel like that? And there's various reasons for that. Okay, it's your senior year. You are well over a third of the way done, well, pretty close to a third of the way done with school. And a lot of you are going down to the school counselor to ask questions probably for classes for next year or applications or both. Something to that effect. And then, of course, there's everything going on here at school with that as far as extracurricular. Let me try that again. Extracurricular activities, whether it's music or whether it's athletics or anything to that effect. All right. think I've said and probably 4 times now. Have you caught that? Because you already have a smirk on your face, so you probably agree. Because I told the chemistry, it's kind of like, because I've been told, my boss told me that I do that a lot. So I can't hear anything you're saying, but I can hear you go, and it just feels like she's got a voodoo doll poking me in the back of the neck every time I think I say that now. So I just kind of go, I don't say that, but I've said it 4 times already. That's how much I've been paying attention to that. And I don't even realize to do it. It's after the fact. It's too late.
Sorry.
Yeah. There could be worse things.
We don't know.
Yeah. Okay.
We won't put you in the doghouse for it. It's a safe space, right?
Yeah. Yeah, we'll go with that. I'll get on the backside of him. Yeah. Hide me, hide me. All right. Now, in handing back those papers, some of you did not use these and that's fine, okay? But it's how you communicate that knowledge. That's what we're concerned about. And from what we handed back yesterday, it would appear that we're doing just fine, all right? So we can safely say these are all aromatics. How many of you are getting good at drawing these things? Nobody? Oh, just it's getting better. My cerebellum is failing me. Why is that? True, it's not just the coordination, but what else? Say that again, you're right. Muscle memory. You think this would be easy? Not a single one of them look similar. You think you could make a hex nut look about the same in size and shape and curvature and but the only thing that is the same is these come to a nice point up top. That's probably about it. And they all kind of do have a little bit of a slight curve there. All right. We're not too concerned about that. We're concerned about this here. Pick one.
Phenol.
Okay, so on that phenol, how do you know you're dealing with phenol? And we'll just keep it, I think it's just easiest. Even the author does this. Just put them at 12 o'clock. Aniline is what? Okay, and then what else? Of course, well, benzoic acid. You can do it one of 2 ways. If you don't like drawing the double bonds, you can do that. Or does that confuse you? If it confuses you, don't do it. Okay? Otherwise, just go ahead and continually write this how we always have. It's the same exact thing. It's just a more convenient way of writing it. All right? And then finally, toluene, of course. And if you see CH3 on there and that confuses you, go ahead and scribble that out and write the structural formula on there. Because once you do that, anytime you're going to react this with a halogen and heat, you're not going to make this mistake then. Why is that wrong? On the bottom. Yeah, there's too many hydrogens. It doesn't have 5 bonds. You're saying 1, okay, 3 more, there's 4, and that bromine, they can't have 5 bonds. They can't do that. All right. So when you do this, and you're reacting that with heat, well, now you wouldn't have any problems with that. All right. Hey, I didn't say and. All right. I'm trying to say that a little more now. And some of you did a good job. You would say, for instance, 3-chloroaniline. And then below you would write or something else. So for instance, with this, you could say 3-chloroaniline, or you can replace that with just one letter. And that would be what? Metachloroaniline. Because when you do that, all right, when you are saying this, that's already established as the number one carbon. How would you know that, though? It's something that we probably have discussed probably well over a week ago, so maybe we don't quite remember that. Because we could also do this I'm wondering if you can actually see that green. Can we? It's kind of faded, but you could also say 1-amino 3-chlorobenzene. Remember, when we use that common name, you're automatically saying this is carbon number 1. And that's fine. That's the reason or an advantage of using that common name. All right? Or you could write this as what we had said earlier, 3-chloroaniline. And when you do this, you eliminate any mistakes that could be made with that of alphabetization when you use that. Because then you wouldn't have to worry, okay, well, we're starting with the A anyway, that's just a coincidence, aminochlorobenzene. So when does this go out the window? Can you not use that? Correct. Okay. So if we had something like this attached onto there, then we can't use that. There can only be 2 derivatives on there. There can only be one here and something else on the ring. Once you have 3 structures on there, remember you can't use that shortcut. Then I think on every paper that was handed back, I circled intentionally, it was like 17 or 18 for a specific reason. At least I believe I circled every one of them. Because you drew it correctly, it was just named incorrectly. So I see you have yours out. Okay, so, all right. If you really, really have a great grasp or understanding on why would we circle that? You drew it correctly, but what's wrong with the name? If you can answer that, you are well on your way to doing very, very well, probably for the rest of the semester in this class. It was not intentional. That was a mistake on my part, but you still drew it correctly. Nope, it has nothing to do with that. And sometimes it gets to be a point where, yeah, I'm just not going to figure it out. Okay, and fair enough. It's not a reflection that, oh my God, I can't understand this. No, that's. So I saw something someone go running by the window. I'm not. Oh, they just came in through there. Okay. Must have been the guys outside picking up trash around the school or something like that. Because what does it actually say on that number 17, or the one that we circled? What does it say? Okay. Okay. within the last 5 minutes when we're talking about this, when we use those common names, that means you automatically say that that is carbon number 1. So when we say this, that must mean on carbon number 1 there is a what group? There's a methyl group. So this is carbon number 1. And then notice on your paper it's got 3,5 on there. That would be incorrect. You still drew it right. But when you do this, that's already accounting for 1 methyl group. So then you probably can cross that one off. Because when you drew that, it probably looked something. Okay, you could say that that was maybe, because we notice we don't even have a number 1 on there, do we? None of them. We got 2, 3, and 5. So what you probably might have done is say, there's 1, 2, and then some of you have to think back on what that, isobutyl is supposed to look like. Yep, I think that's isobutyl, because if we were to shift this one over to here, well, then you would have that tertiary butyl. All right, or no, up to this one, that one's up there. And then what we probably would have done was, and then does that look like what you drew? Say that again. Oh, you put, oh, okay. All right. But if we,
I don't understand why would we know. This volume accounts for 1, but it's kind of the first one, and you still got 1. But that methyl doesn't have to include the one I'm telling you.
okay, so I thought you only, I just glanced at that, thought you only put 1, so you put 3 methyl groups on there? Oh, okay. Well then, what a coinkydink, that was written correctly. I was thinking that confused me when I saw this on here and thinking we already accounted for 1. All right, good, good. Disregard everything that we said there then. I'm going to erase this so we don't get any more confused. Is anybody lost right now? So left outside, left middle, right middle, right outside. Is there anything else you'd like to ask with this? All right, so we've got a few minutes. The rest of the time is yours. Make sure your names are on them papers, and I will collect them. We'll catch up to you next time.